Greater learning, greater opportunities. This video is brought to you by Greater Commons. Greater learning, greater opportunities, greater life. Visit us at greatercommons.com.
Hey, what's up, people? So we are going to talk about HTTP status codes. We're going to look a little bit about some of the specifications for requests for comments and what goes over with the request and what comes back with the response. We're talking about web programming with Go. You're looking at some Go code right there on my screen to create your own server, your own MUX, if you wanted to write it from the ground up. But the main thing we're going to talk about are status codes, and in particular we're going to talk about redirects. We've visited this once before, and I just want to make sure that you have the resources to reference, when you need to look at them, and you have a starting understanding of status codes. So NetHTTP, godoc.org, NetHTTP. If we go and we look at that index, right, just beneath the index for the NetHTTP package, we have right here all these HTTP status codes, And so we've already talked about them a little bit. If you look at Wikipedia status codes, they have the deal right here which tells you the different categories. So things in the 1x are informational, the 2x, anything in the 200 series is successful operation, 300 series is a redirect, 400 is a client error, 500 is a server error, 900s are proprietary errors. And so it'd be kind of interesting just to look at this and see what they have to say about them in here. But this is where you could reference, if you have to set a status code on something, like, oh, what's that status code mean? You could come in and start taking a look at some of these status codes. I put together a little page and a little sort of picture deal to look at. So the page is right here, status codes. We saw it once before. We'll look at that in a second. But the first thing I just kind of want to look at is, some of the basics of the web and how request response works. So this is the basic HTTP round trip cycle. Client makes a request and the server fulfills that request with a response. And we've seen that in our signatures for the functions where we use handle func and then it has to point to a function that has a specific signature where it has a response writer and a pointer to a request right from the HTTP package. And so that's the request and the response. And each request, if you notice there, each request has components to the request. So the request will have a request line, it'll have headers, and it'll have a body, or the payload. And the response will have a status line, it'll have headers, and it'll have the body, or the payload. All right, and we've already seen some of those headers. We took a look at this before, and we saw how could set some headers. So if we go to Reddit, and we bring up developer tools, and then I go and I look at network and I refresh and then just stop it and go to the top and click on that file. I could see the headers right there. Right? Request headers, response headers. And so the request headers is telling with the request, the server, hey, I accept text HTML, this kind of stuff. And then the response header says status 200, so there's your status code. Right? Everything's okay, status 200. I thought originally, have I showed you guys my license plate on my car? I haven't, have I? My license plate's HTTP 301 on my car. And I thought originally I'd get HTTP 200. I thought, oh, that'll be cool. Somebody already has it. But status okay. Right? Like, that's cool. That's a cool license plate. It's geeky. Only geeky people know about it. I got moved permanently. That's fine too. I like it also. But content type. We've played with content type here, text, HTML, charset, UTF-8. Right? So when we respond, we send back to the browser. We say, hey, this is text HTML. And then the browser gets that. And the browser is sometimes called, in documentation, the user agent. Kind of a weird phrase. Right? But the user agent is what the browser is called in documentation sometimes. So the point being is we're just learning a little bit about the technicalities, technical details of how is this stuff structured, right? Because it's a protocol, HTTP, Hypertext Transfer Protocol. And the networking protocols are rules of communication. So that's what a protocol means. Right? We have certain protocols which we follow so that we could communicate. I am following protocols right now for communicating with y'all in the classroom, culturally established. Right? If I was facing this way, that would be a weird protocol. Maybe in some cultures this would be like seen as a sign of humility. Like it's the message that matters, not the messenger. So you can try to remove the messenger, but it's weird in our culture. So we have protocols for everything. And this is the hypertext transfer protocol. And every request has a request line, headers, and body, and every response is a status line, headers, and body. And so the request line, status line, those are just phrases for pretty much the exact same thing. They're slightly different. And you can find all this documentation in RFC 7230. RFC stands for Request for Comments, and the RFCs are put together by the IETF, Internet Engineering Task Force. And so you could sometimes narrow in on your Google search to find the exact specification for something by saying like, hey, I want to know cookie attributes RFC. And that will bring up cookie attributes RFC, will bring up the exact, IETF cookie, RFC cookie attributes. Right? We'll bring up RFC 6265. Sweet. And I could click on that, and I could look through here and find things about cookie, syntax, semantics, right? And here's set cookie header, and expire attribute, max age attribute, domain attribute, path attribute. So these are like the official documents that they're recommendations. So this is the recommendations for how the internet and the worldwide, because anybody could contribute to it. So if you want to contribute in the way that works with everybody, you follow these recommendations. Otherwise, you're creating your own network, which isn't going to work with this stuff. It's not like internet enforcement police come around and say you implemented your network incorrectly. It just doesn't work with the internet that everybody else has put together, right? So that's kind of how that works. So the recommendations. So here's what a request line looks like. A request line is going to have a method, a space, a URI, a space, and an HTTP version. And so in practice, that would look like, let me just see if we could do RFC request line, right? RFC HTTP request line. And so here we go, and then we'll just look in here for request line. And nothing, request line. And there's the request line would be get. There's a get, and then the URI. And URL, URI, you sometimes hear those interchangeably, right? And there is a slight difference between them, but for all intents and purposes, don't worry about it. Like if you're having to name variables in a program, sometimes you'll start out with URL, and if you run out of that, call the next one. You have to, if you need another variable to refer to URL, call URI, right? But URL, URI, pretty much the same thing. But there you see the request line. It's got the method, a space, the URI, a space, and the HTTP version. Okay, so that's the request line. It's just saying, hey, this is the method. It's get. I want this resource, and I'm using this HTTP version. Okay. And here it talks about request URI is equal to that, and I'm just looking to see the methods, and the request line is equal to the method, the space, the request URI, the space, the HTTP version, carriage return line feed. All right, so that's the request line. And then we have the status line, which is the HTTP version, the status code, and the reason phrase. So this is where status code kind of comes in. So the request comes over, and the request looks something like this. Okay, that deal right there. And then the server gets that request, and so now we can look at RFC HTTP status line. And here's status line. And a status line has the version, the space, the status code, the space, and the reason phrase, and then the carriage return line feed. And so an example of that would be like, and so here are those things: informational success, redirection, client error, server error, and different ones here. 200 OK, created, accepted, right? Different ones there. And then I'm just looking to see if they have an example here. La-di-da. Not seeing one. But that's what comes back from the server to the client. So it gives you the version, the status code, and the reason phrase. So if you built your own server, and that code is in this pathway, if you're watching this online, you could find that code at GitHub, goes to 11, and then click on the Golang web dev directory. But in here we have things like building a TCP server for HTTP, understanding TCP servers. And so if you look at those, and it might be interesting to run some of that code, like here we have understanding TCP servers. So let me just not show that for a second and see if we could find one that shows the status line. This will be kind of interesting just to kind of walk through understanding TCP servers. And so here we have the packages fumpt, IO, log, and net. Right? And so it's not net HTTP, it's just net. And that's a totally different package, godoc.org/net. And if you look at the net package, right, there's net and then there's net HTTP, as like HTTP is built upon the net package. Right? The net package has things like TCP, UDP, right, that you could do in here, and IP. And so you could use these different network protocols in the net package. And so here we're saying net listen. And so the listen one, find listen. And look at the index. It takes network to listen on and a listening address and gives us a listener and an error. So network to listen on, type of network, the protocol, and then an address. Right? And it gives us back a listener and an error. So here we have a listener. And so we defer that listener close. But once we have a listener, what does a listener give us? Type listener right here. Right? So listener gives us type listener. And type listener, we could come up here and look at that, is an interface, accept, close, and address. Right? So we have accept, close, and address. And so we could do for, and we could just eternally loop. And any L we could accept, right? Anything that comes in, we could accept it. And when we accept something, that's going to give us back a connection and an error, right? So it's just kind of interesting. It gives us a connection and an error. So with our connection, we can now write that, write the connection, hello from a TCP server, and we could write that to the connection. And then keep writing things here just in different ways back to the connection. We did it with write string and fprint. And then we could close our connection. And then once we do it, we'll come back and we'll listen for something more. So if we were to run that code, and there's a little README here, on Windows, you can install Telnet. On a Mac, it should already be there. You're going to start main.go and go to another terminal window and enter this. And Telnet allows you to communicate on TCP. So I could Telnet to that. So it's just kind of interesting. And we're just doing a little bit of a tour here, getting around to maybe seeing the status line, request line stuff. But I'm going to change directories. Go into GitHub and goes to 11 and Golang web dev. And we are in 0.15 and 0.1. Go around main.go, launch a new one, and in Telnet, and I do localhost 8080, localhost 8080, and so I'm going to connect to this server that's running. I'm listening on TCP, and when I connect, right, I connected to that server, and that server wrote back on the connection, hello from TCP server, how's your day? Well, I hope. Hello from a TCP server, how's your day? Well, I hope. Wow, that's pretty interesting. So this is just FYI stuff. Okay, so that's like the first deal. And that's writing to a connection. You could read from a connection. So we wrote to TCP connection. To read from a connection, get our listener. So net listen, TCP 8080, get our listener, and then do our loop. And anything that comes in, it's just listening. Right? It's just listening, and oh wait, the phone rings, I'm going to accept that, gives me a connection, and then I'm going to do go handle. So Go is a Go routine, meaning launch this in its own thread. Just kind of interesting. Don't like sweat the details. Just sit back and enjoy the tour of the countryside. You're becoming acquainted with the little countryside here. Later, if you want, on your own time, you can get on your bicycle or your motorcycle, your moped, or your car and go back and visit these places and get to know them more intimately. But right now, we're just taking a fast ride through the countryside and kind of just being exposed to like, oh, look at the terrain here. This is interesting terrain. So just take this all kind of casually, right? Like show and tell kind of, you know? So here we launch a Go routine, which means that instantly this just goes back to the top of the loop and is waiting to accept anything else that comes in. So this could handle more than one connection at a time, right? And every connection that comes in, it launches it out into its own Go routine. And that's actually how default servmux works. Is it uses Go routines for each incoming request, gets sent out into its own Go routine. Kind of cool. And so that Go routine handle, we pass in that connection, and then we use buff.io new scanner, and we scan that connection. That gives us a scanner, and then the scanner, for scanner scan, right, returns a bool, and anytime there's something more there in to receive, it says true, and when it's not, it's false. And then we say, whatever there is there to receive, give me the text of it. And that gives us a line of text. And then we print out that line, and then we close our connection when it's all done. And we never get here. We have an open stream connection. How does the above reader know when it's done? Right? Because it's just basically always scanning, waiting to see when is it done. So the code never gets down to here. Right? It never is like... It's kind of like if you're on a call, like how do we know when the call's finished? Maybe the person's still going to say something. Like we're always waiting there to see if they say something more. And as soon as they say something more, we do another iteration of the loop, but then we're just waiting. You still there? Oh, okay, I wasn't sure. All right, we haven't told the program how to get out of it yet. So that's kind of interesting little program. And then here, again, we never get here, same deal. And we're reading and we're writing. And then here, I'm just looking for the one where we get to start seeing the header. We pass in the connection, and we set a deadline. So connection set deadline, and now after 10 seconds, so time now, add 10 seconds, right? After 10 seconds, the connection's going to close. So now we will get here at the connectional timeout. This breaks us out of the scanner loop. So that's kind of cool. So let's run this and see what happens. And listen, bind address is already in use. So I need to close this one, Control C, and go in here, go run main.go. All right. So I just did localhost 8080 on my browser, and I'm built on top of TCP. Our web servers are built on TCP, right? So I did, in my browser, I went to localhost 8080, and I made a request. What's the first thing in the request line? What's the first thing in the request? The first thing in the request is the request line, right? So here is the first thing in the request line, and then the headers, and then the body, right? So here's the request line, and then here are the headers. And if we had a body, we'd have a body. Request line, and then the headers. And so you could take that request line coming in, and you could say, all right, that first line, I'm going to parse it, split it up on spaces, and I have my method, and I have my URI. So now I could say, is it coming in at this path, and is the method get? Is it coming in at this path? Is the method post? So we're going from the documentation, right, the RFC, IETF. This is what the HTTP request response looks like. It has a request line, headers, and body. We're going from that documentation, and from TCP, we could build up our own server. Wow, that's kind of mind-blowing. And we could start parsing in the text that's coming over, because it's just text. right? We could start parsing that and using it and building up our own serve mucks. And as a matter of fact, that's what the code right down here does. Right here, right? So you're listening on TCP 8080, you get your listener, and then you loop over that, and every time something comes in, you accept it, you get a connection, you fire that out into its own go routine, you handle it, right? And then you defer the connection to close it, and you get your request to handle your request, and then buff out a new scanner, you scan over it, and you have I is equal to 0, and then print line that line that comes in. And if I is equal to 0, we do mux connection ln. And with that mux connection, and we pass in our listener, we come down here, and then we take strings, fields, ln 0, right? So strings and fields, let's see what that does. Fields splits the string s around each instance of one or more consecutive white space characters. So split up that first line, and turned it into a slice, and we said in index position 0, give us that, which is the method. In index position 1, give us that, which is the URI. And so then with that method and that URI, right, with the method and the URI, that's the request line, we could then say, hey, if the method is get and the URI is this, then we're going to run this code. And we've just kind of built our own serve mucks from the ground up, from TCP. Now there's always, programming requires that you always have to work to the edge of understanding. You always work to the edge of understanding. You will never have full knowledge of any application you ever write. Any application you ever write, you'll write it to the edge of your understanding and you'll stop. Computers are all about abstraction. Very few people understand the internal guts of processors. Like down on the microcosmic nano level, like circuits, switches. Like we know it's zeros and ones and that there's circuits and switches in there, but man, who knows how all that stuff is happening on machine language, assembly language, your instruction set for this exact CPU, moving things in and out of registers. Like those are complete classes in computer science to understand that stuff. And so we all operate on abstraction and always to the edge of understanding. There's always stuff we don't understand. Great, so we wrote it down to the TCP level. How's TCP work? Oh, let's go take that class. And that's just going to open up more stuff about the network layers. And I don't understand those other layers, So it's always a process. But I just thought that this was really an interesting little deal to kind of point out. And how many people kind of get a sense like, oh, okay, I get that. This is the basic thing. Every request and response has a request line. Every request has a request line headers and bodies, and a response has a status line header and body. Right? Okay, I could see that. That's just like HTTP. That's the specification, the RFC IETF. You guys see that? Yeah, it's just the way it's written out. You don't have to solve anything. You just accept it. And where would, in a response, where would the HTML be? In the status line, in the headers, or in the body? It'd just be in the body. Here's your HTML. Right? Here's your CSS. Here's your JavaScript. The status line is going to be, right, the HTTP version, the status codes, and the reason phrase. 200 OK, right? It would be 200 would be the status code, and the reason phrase would be OK. 404 not found. 404 would be the status code, and not found be the reason phrase. And so the body is where your HTML, JavaScript, CSS, all that stuff gets sent in that. What about if I submitted a form? If I submit a form, in which of those 6 categories in those 2 boxes, where's the data from the form going to be? So when a client submits a form, it's going to be in the body of the request. Okay, the payload. Also kind of sometimes called the payload. That's kind of cool, right? I don't understand this stuff completely. Like, I couldn't go write that TCP server from scratch. That's like a lot of thinking there. And Caleb Doxey showed me how that worked. He did write it from scratch. And in like 12 minutes, I was like, wow. You know, he's like, it's like this, it's like this, it's like this. So he has awesome command of it. I wish I was a better programmer. I love programming. I think it's cool. I think it's fun. But I've only been at the game since 2013. Because the school is like, we need somebody to do it. I said, all right, man, I'll figure it out. They said, go for it. So, you know what you know. And I've learned a lot since then, but that stuff's still mysterious to me. But I just wanted to give you all a little introduction to it and let you go dig around in it when you feel the inclination for it. Because there's some interesting, fascinating stuff in there. And it introduces you to some new ways of doing things. And it's written by a guy who really knows this stuff intimately well, Caleb Doxey. But you get a little sense of like, okay, right, you've learned some new things. You've learned the request and response. They each have that status line or request line and then the headers and the body. And this is all based upon requests for comments by the IETF, the Internet Engineering Task Force. And the request line, stats line is that first line that comes over, right? So here's the request line, the method, the URI, and the HTTP version. It's that first line that comes over. This one's slightly different, right? Method, URI, and HTTP version. And if you wanted to, you could start parsing that, right? It makes sense. I could take that string and split it up and start getting the data out of it and doing stuff with it. And then all the headers are down here. And, you know, so there are some examples of the request line and the stats line. I had some examples right there. HTTP 1.1, 200, okay. You guys see those examples? You gals, guys, gals, y'all. And so status code and reason phrase are the things we're going to be looking at. And you can find out about those in RFC 7231. So we could go just check that and make sure my notes are right. 7231. Some reason I've got German going because I connect with my VPN. And status code and reason phrase. Semantics and context. And let's look down at the index. And we'll search the index for status. Status codes, right? And there they all. And reason phrases next to them. So this is a good place where you could go and you could dig it up. But when you read this stuff, let's read one that we're familiar with, 404 not found, because we think, oh, everybody knows 404 not found. We all know what that is. The 404, but when you put it into engineering speak, it's going to make you question whether or not you understand it often, at least for me. The 404 not found status code indicates that the origin server, so origin, that's interesting. And if you start working with GitHub, right, GitHub often will refer to the origin master. I just think it's the origin from which everybody's putting stuff and the origin from which everybody's pulling stuff. Right, but here's that phrase again, origin server. Makes me feel like if I studied comp sci instead of economics and business and finance, you know, you probably learned this in the networking classes. But here's the origin server. Did not find a current representation for the target resource or is not willing to disclose that one exists. All right, so it didn't find it, right? Not found. A 404 status code does not indicate whether this lack of representation is temporary or permanent. The 410 gone status code is preferred over 404 if the origin server knows, presumably through some configurable means, that the condition is likely to be permanent. So if we've deleted some route, we could always leave something in there that says 410, this thing's gone, if somebody asks for it. 404 response is cacheable by default, i.e. unless otherwise indicated by the method definition of explicit cache controls. So, okay, I thought I knew 404, but there's stuff in there that I need to go look up. It's cacheable by default unless otherwise indicated by method definition or explicit cache controls. Now I need to go read RFC 7234. Or the 200. But the point being is you operate on the edge of understanding. And as Dr. Seuss said, I don't know how now, but when I'm done, I will. I don't know how now, but when I'm done, I will. And the way you figure something out is you jump in. You say, all right, let me do a little digging and go into the area I don't know and read it a little bit and get some understanding. So here's the 200. We're not going to read it, right? But you can see, wow, there's a lot of stuff to say when all I really think is that you need to know is it means I found what you're looking for. Like, whoa, they had a lot of stuff to say about that, right? I found what you're looking for. They wrote like 7 paragraphs. There's a lot of nuance there. So if you really want to master this craft, you know, this is what you do in your spare time. Your wife, your partner is going to be reading a novel, and you'll be like, RFC 7234, 7230, 200, interesting. I wish I could, if anybody watching on the web knows a great book that explains all this stuff, like anybody who's ever written a really great book about it, I'd love to see like that book, so I have yet to find one. I love the old Cold Fusion book in the early 2000s by Ben Forda. He had a couple of chapters that talked about some of this stuff really well. So the 300s are redirection. And like 301 is move permanently. That means that I wonder if I should talk about status codes in this one or show you the next example, because we kind of did a whole lot of like foundational stuff, but I think I'll just keep it rolling. So 300 is redirection. So if you respond with your server status code 300 reason phrase move permanently, you send that back to the client. That browser is not going to ask you ever again, the server, for that URI, that location, right? It will automatically redirect to whatever location you told it to go to. So they're not hitting your server again until they clear their cache, okay? On their browser's cache. And then they'll forget that and they'll do it again. But move permanently means once you tell somebody, like you'll say, hey, give me the route. I have pictures of this actually. We're going to see it in a second. Redirection, we have see other, 303, see other. Okay, so see other is always going to be get. And 307 is a temporary redirect. And there's also 302. But 302 got bastardized a little bit. So these are the 3 ones in redirection to focus on. So 301, move permanently. This is what it looks like. The client makes a request, so this request line, the headers, and the body all get sent over. And the request line is get this URI, this version, right? That's the request line. The server says status line HTTP 1.1301, move permanently, headers and body. In the header, the location is set to doggy, right? So you ask for dog, that moved permanently, it's now always at doggy, okay? So the client then says, well, get doggy, dog. Sorry, joke. Get doggy, HTTP 1.1. And the server responds HTTP 1.1 200 success. Now, if the client said, give me dog again, it wouldn't even go to the server. It would just automatically, on the client, the browser would say, give me doggy. It'd get doggy and give it to the client. So that's moved permanently. Once it's registered in the browser that this is moved permanently and no longer hits the server for this route, if that route's asked for again, it remembers, oh, that's going to be doggy. I'll get doggy for you. That's moved permanently. Just interesting. How many people just don't care? How many people find this interesting? Cool. Here's 303 see other. So before we jump into see other, let me show you this other resource which I put together for you. And that resource is right here. In redirect, 028 redirect, status codes. Okay, so I'm just going to pop this baby open. And in here I talk about move permanently, and I have some verbiage in there. Okay. And then we have 302 found. 302 found was supposed to be an otherwise identical request, but most web browsers implement it to always have get, regardless of the original method. Right? And so web browsers did not implement it correctly. And so people created, the RFC IETF created 303 see other, and it always uses the get verb. So see other, move permanently is 301, never hitting the server again. See other is going to be fine. We're moving you over to show you some other route. You asked for dog, we're going to move you over to doggy, and even if you came in as post, we're moving you to doggy as get, right? So it's a redirect. And a temporary redirect, 307 will keep the same verb as the original. So here's how my friend Daniel described it. This is 303, see other, is good for using once you have processed a form submitted by post method, and now that the form is in process, redirect to a new URL using the get method. And 307, if you use this redirect and the method was post, then redirect to the location URL, and the method of the redirect will also be post, so all of the data will go with you to the new location, right? So if you needed to post to a new location, there might be, I don't know. I think you shouldn't ever have to use something like that, but anyhow, just nuances. So don't use 302 found. Use 303 or 307. And here are the pictures. So here's 303. See other. So it's always going to be get. Get cat. 303 see other, and then the header location caddy. Well, get caddy, HTTP 1.1, HTTP success, there we go. Post cat, 303 see other, location caddy. Get caddy, right? So it changed it to get. The original was post, it changed it to get. So 303 is always get. 303, here's another 303. So that's highlighting that, post and get, right? You can see it changed the method. And then 307, temporary redirect, is get cat, and it says, oh, 307 temporary redirect, location caddy, get caddy, and so the browser says, all right, well then get caddy for me, and success. Post to cat, and it's like redirect, location caddy, right? 307 temporary redirect. And so the browser then posts to caddy, because this is 307, so the method post was maintained, right? Post here, post there. 307, the method stays the same. 303, the method gets changed to get. So that's just like a little bit of interestingness. And that comes up when you do redirects. Right? So you have to be like, oh, which one should I use? Now you have a resource to consult and you have some basic understanding of it. Anybody have any thoughts or questions about all that?
Do we put these codes in our code when we're coding? Trying to find a different word to use there.
Yeah, absolutely. So if I do like, let me just do, search this whole project for 303. And so here are some 303s. Testing, go testing applications, redirect. That's just my deal. Let's try 307. I don't see any examples coming up right off the bat, but we'll see some. Cool? Any other questions? Very well.
This video is brought to you by Greater Commons. Greater learning, greater opportunities, greater life. Visit us at greatercommons.com.